Welcome back to the Hangover Club. In the last video, I went over making your very own ERC20 token with the use of smart contracts within Remix, which is the IDE to create smart contracts on the Ethereum blockchain. Today, we will be going through a more complex smart contract, which will give you an idea of how to implement a voting system into your projects. The following contract is quite complex, but it will show you a lot of the features that Solidity, the language we use to write the code for Ethereum, has within it. Firstly, the main issue we have whenever a voting system is implemented is to make sure that it is one valid vote and cannot be manipulated. In this contract, we will go through the code line by line, giving you an idea of what each snippet of code is there for. In the end, it will show how a delegated voting system can be implemented so that the counting of the votes are automatic, but most importantly, transparent. If you saw the last video, you should know the website we will be using for this example. It will be linked in the description below, if not, but it's called Remix. This is where we write all our smart contracts for the Ethereum network in Solidity, if that be on the testnet or on the mainnet. On the previous video, we showed how you would use this for submitting a smart contract or deploying a smart contract on the testnet. We'll go through each line of the code here, as you can see, which is all commented, and it'll give an insight onto all the features and how it all comes together to create this smart contract to vote. Firstly, the voter variables. Here you will see we have certain variables against the voter. These variables is a model-like structure which represents a single voter on our contract. So for example, the weight is accumulated by the delegate. The vote is basically to tell us if that person has already voted or not. The delegate is the delegation of the person's address that has voted, and then the vote itself is the index of the vote, which should just be a unique identifier to the vote that has taken place, which will be used later on to make sure that the counting is automatic and transparent. Next stage is the proposal and setting up the proposal. The proposal involves the name of the proposal, so what your voters are voting on, which can relate to specific things within your project, the roadmap of your project, different ideas that you and your team might have within your project that you want to ask your holders what their opinion is on it. And then obviously below, another variable, which is the vote count itself. This is the number of the accumulated votes over the period of time that the smart contract has been released to the holders and the voting system itself. Very good way of interaction with your project and the holders themselves. It also gives you more tools to give them exactly what they seek from your project too. So then moving on, the next one is the address of the chairperson themselves. So this would be the project holder, the person that owns the project, that owns the smart contract, that is putting out the vote itself. So this might be the person that decides what the vote is about, and so on. Below, this is just declares the state variable, which stores the voter structure for each possible address. So it's just a mapping system. Moving on. Now, one of the constructors is to create a new ballot to choose from one of the proposal names. So, for example, for each of the provided proposal names, create a new proposal object and add it to the end of the array. This simply means that each proposal will be a different option for a user to choose from. We've got all the constructors set up, the variables set up for the smart contract itself. We will then move on to a core function of what the smart contract is doing. So this gives the voter the right to vote on the ballot itself. This may only be called by the chairperson themselves with the authority to do so. If the first argument of the require evaluates to false, the execution will terminate. All this means is that if the chairperson or a voter has already voted, then this is the function that will stop them from doing so again. It will terminate the function and terminate the smart contract. So this is used to consume all the gas into the old EVM versions, but not anymore. It is often a good idea to use require to check functions are called correctly. Require is basically within that function, it is required to go through that process before it can carry on. So, as a second argument, you can also provide an explanation about what went wrong. So, to give the user more insight to why they may not be able to vote, there could be certain requirements to vote, a certain amount of Ethereum that you have to hold to be able to vote, for example, or a certain amount of tokens that you have within your project that someone might have to hold to have a certain privilege to vote. So that's just an example. Here you see that it's a requirement that only the chairperson can give the right to vote, and then the next one is if the vote has already taken place from a voter. So this is the point where you will not be allowed to vote more than once on the smart contract. Depending on your smart contract, there might be different requirements and different procedures. You might want to implement something along the lines of allowing someone who holds an X amount of your tokens within your project to have more voting right than someone that doesn't hold as much tokens. Is the delegate. The delegate is your vote to the voted to. So, firstly, we assign the reference of the voter, and we also have these require blocks again to check for if someone has already voted or if self-delegation is not allowed. So this will go more into it. Forward the delegation as long as the to also delegated. In general, we have to be careful with loops within any contract, because if they run too long, they might not only use more gas fees that is available within a block, but it might get stuck completely, and that would be a very bad thing for this contract, because then it would mean that your contract is completely useless. So to stay away from this, we put a require within the loop which allows us to find it, and if it finds a loop in the delegation, it will stop the smart contract and send a message to the sender, which would be the voter. Since sender is a reference, this modifies the voter message.voted. This is just a storage type. Voters cannot delegate to wallets that cannot vote. So this is again a requirement. Voters will not be allowed to delegate to their wallets that cannot vote. This is the point where we say that the sender has now voted, because it has passed all the requirements previously within the smart contract. If the delegate already voted, directly add the number of votes to the proposal. Else, if the delegate did not vote yet, add to her weight itself instead. After that, we will have the function vote itself. Give your vote, including votes delegated to you, to the proposal. This again will include requirements. That will first be the weight of the sender. Do they have the right to vote within the smart contract? The second, again, is to check, have they already voted? If proposal is out of range of the array, this will throw automatically and revert all changes. This is basically a backup, which means that it will not cause any issues with your smart contract if you put this within it. Later down the line, we have a function for the winning proposal. This computes all of the votes taking place and shows the winning proposal that has been voted on. It keeps a count of the number of votes relating to each proposal within the smart contract. Finally, we have the winner name function. This calls the winning proposal, which is above here. This will get the index of the winner contained within the proposals array. Think of an array as just a list of options for the vote with a number next to it, which will have the amount of times someone has voted against that one. And then this will return the name of the winner, and therefore will allow us to know exactly what proposal on that particular vote has won with the most amount of votes. As you can see, three main things in relation to a smart contract when in terms of voting is the voter themselves. Are they allowed to vote? Have they voted? And the index of the voting on the proposal. The second is the proposal, the name of it, and the vote count against it. Again, this would be a list. There would be several different options within the vote which would be classed as a proposal and would be voted on. And the third is the chairperson themselves, the person putting forward this vote for your project. So I hope that all makes sense. I know that it's a little bit complicated, but the more that you look into Solidity, the more that you play around with Remix and the IDE on the Ethereum network, use the testnet, publish or deploy onto the testnet, it will give you a clearer understanding of how these things all come together and how you might want to implement certain tools and certain features when you create your own ERC20 token. So thanks for watching, and I'll see you next time.